So here, we save it to the data frame, and then let's make a columns. So df columns is the first one is the estimate for market factor. Second one is the estimate for size factor. Third one is the estimate for value factor. Okay, so we set the names for each column. And then I can print df describe. Okay, describe and this one, good. And then standard error, print. Now, sometimes you also use median estimate. So here, median estimate here, and then df, and then I say median. Now it is a matrix, so I have to decide matrix. So df x is 0. So median matrix, median is this one. Okay, axis is 0. Okay, let's say it's NP. NP. How about DF? I'm DF median. How about this one? Yes, this is also fine, but this is not so pretty. Can I transpose it? DF median. Yeah, it is doesn't transpose. So actually, I prefer NumPy. NP. Yeah, median F X is equal 0. I prefer NumPy. So it is a median estimate. And then let's say standard errors. Standard errors without Shanken correction. We have to do Shanken correction, but there is another topic for. So let me skip that part. So Shanken correction, and then here standard error, standard deviation, and then we have to divide it with t. Okay, without Shanken correction. So yeah, like this. Okay, good. So far so good. So far so good. Okay, and then actually let's do check the answers with linear algebra. Linear algebra, okay? X prime, X inverse, X prime y thing, okay? Linear algebra. So actually linear algebra is very convenient. So for step one is what? Step one is time series regression, right? Time series regression. And then step 2 would be cross-sectional regression again. Cross-sectional regression. And for step 1, let's define X. X is NP, C, and then we have to add in the regression because we have to do everything from the scratch. So we have to add a constant term. So NP1, NP1's T, and then of course we can add factors. Then this is our X, right? This is our X. Nothing difficult over here. And then we construct M matrix. M matrix is the same. X prime multiply X, and then we have to inverse it. NP linear algebra and inverse of this one, and then x prime. This is M matrix. And then P hat, as we explained, P hat is simply M multiplied by this entire data matrix, right? Right? And then now we define P hat is now shape. Let me check shape. Shape is 4 multiplied by 20, but I don't need the coefficient for the intercept sum. So what I can do is P hat equals P hat of the from 1 to the end and the entire 2000 form for vector. And then I transpose it. P transpose it. And then P hat shape. Okay, 2003, that's fine. Okay, so I estimate P hat. Okay. And then time series regression. For time series regression, I have to define X again now. And then we use the estimated P hat as a new explanatory variable. So NPC, and then now NP ones, and then cross-sectional regression. So we have n number of forms for each time, and then I include the P hat. Okay, and then again I can define M matrix over here, M matrix over here, same. And then now I get the F hat. F hat matrix is here. The important thing is M matrix multiplied by, now it is time series regression. So I have to transpose the data, right? It is not time series regression. So we have to transpose it. So it is like row by row regression. In the previous one is a column. In the time series regression, it was like a column by column regression, but now it's a row by row regression. So I have to transpose it, right? Transpose it. And then, well, now I can do this on simultaneous because I don't need it for intercept term, and then I have to transpose it. So I copy this one. Okay. F hat M data T M data T. Let's do this one first. No, because I have to do matrix algebra first. Okay. F hat, and then I can simply describe F hat. So df equal data frame PD data frame F hat, and then I can copy this one. Well, yeah, actually I can copy this one together. It's same. So I can check the answer. So and the answer should be same. Yeah, exactly same, right? But you know, this matrix algebra is much more simpler. Okay. Next, important part. Next, we will learn how to get, we'll study how to get standard errors more accurately.